Hello everybody. As you might have guessed, I'm not here today. I apologize. But I do have something for you guys to do. Now, over the summer, NASA landed a rover on Mars. This is one of the first times we get high-resolution pictures of Mars. It was a very, very expensive and very long journey for the rover. The rover's name is Curiosity, and we're going to try and figure out today, at what speed did the Curiosity rover go? Mars is a long, long way. In fact, Mars is 173 million miles away. That is huge. It took 8.5 months for the rover to go from Earth to Mars. My question is, how fast was that rover going? Here's some conversions to help you. There are 30 days in a month. Average month. Obviously, February has anywhere between 28 and 29. Other months it's 31. But we're going to say 30 days per month. Let's make the calculation easy. 24 hours in a day. All right. Pretty sure everybody knew that one. 3,600 seconds in an hour. That I'm not so sure you guys knew. But I want you to use these conversions to figure out how fast did the Curiosity rover go between Earth and Mars. Now there is homework. There is homework. But I'll get to that in a minute. Welcome back. Hopefully, if you did everything right, your answer should be 28,000 miles per hour. That's very, very fast. Now, for homework, I want you to do something else. NASA would like to explore the outer reaches of the solar system. There's many, many moons of Jupiter that are very, very interesting to scientists because they may actually contain water. But the distance between Earth and Jupiter is enormous. It's 450 million miles. So the question is, using the technology we have today, using that speed, 28,000 miles per hour, how long would it take to get a Curiosity rover onto Jupiter that's 450 million miles away? That's your homework. Write it on a separate piece of paper. You're handing it to me. You're handing it in to me on Wednesday. Hello everybody, it's Tuesday and I'm still not here. So let me give you something to do. What we're going to be doing today is we're going to be figuring out how far did Katniss Everdeen run on that first day of the 74th Annual Hunger Games. Let me give you a few facts. The Hunger Games started at noon. Noon is when all of the tributes heard the bell and started. Sunset that day was 7 p.m. The average speed that Katniss Everdeen ran and walked is 13 miles per hour. Your mission is to find out just how far she was from the cornucopia by the time sun set. There is homework, and I'll tell you that in a bit. Oh, so Hunger Games was a bit too easy for you. Well, I have one. This should take the rest of the period. I love reading, particularly dark stories. Stories about fear. I was reading this one story. It's called Dagon. It's written by H.P. Lovecraft, a predecessor of Stephen King. Let me read you a little bit about it. It was in one of the most open and least frequented parts of the broad Pacific that the packet of which I was supercargo fell victim to the German sea raider. The Great War was then at its very beginning, and the ocean forces of the Hun had not completely sunk into their later degradation, so that our vessel was made a legitimate prize, whilst we of her crew were treated with all the fairness and consideration due us as naval prisoners. So liberal indeed was the discipline of our captors that 5 days after we were taken, I managed to escape alone in a small boat with water and provisions for a good length of time. When I finally found myself adrift and free, I had but little idea of my surroundings. Never a competent navigator, I could only guess vaguely by the sun and stars that I was somewhat south of the equator. Of the longitude, I knew nothing, and no island or coastline was in sight. The weather kept fair, and for unaccounted days I drifted aimlessly beneath the scorching sun, waiting either for some passing ship or to be cast on the shores of some habitable land. But neither ship nor land appeared, and I began to despair in my solitude upon the heaving vastness of unbroken blue. The change happened whilst I slept. Its details I shall never know, for my slumber, though troubled and dream-infested, was continuous, and when at last I awakened, it was to discover myself half sucked into a slimy expanse of hellish black mire, which extended about me in monotonous undulations as far as I can see, and in which my boat lay grounded some distance away. Though one might well imagine that my first sensation would be of wonder at so prodigious and unexpected a transformation of scenery, I was in reality more horrified than astonished, for there was in the air and in the rotting soil a sinister quality which chilled me to the very core. The region was putrid, with the caresses of decaying fish, and of other less describable things which I saw protruding from the nasty mud of the unending plain. Perhaps I should not hope to convey in mere words the unutterable hideousness that can dwell in absolute silence and barren immensity. There was nothing within hearing, and nothing in sight save a vast reach of black slime, yet the very completeness of the stillness and the homogeneity of the landscape oppressed me with a nauseating fear. The sun was blazing down from a sky which seemed to me almost black in its cloudless cruelty, as though reflecting the inky marsh beneath my feet. As I crawled into the stranded boat, I realized that the only one theory could explain my position. Through some unprecedented volcanic upheaval, a portion of the ocean floor must have been thrown to the surface, exposing regions for which innumerable millions of years had lain hidden under the unfathomable watery depths. So great was the extent of the new land which had risen beneath me that I could not detect the faintest noise of the surging ocean. Strain my ears as I might, nor were there any seafowl to prey upon the dead things. Well, that was pleasant. So his situation seems pretty bleak. Adrift in a boat, and he didn't really know where he was. We're better navigators than he is. What happened was, he escaped from that German boat, and he was adrift. Drifting speed is about 3 miles per hour. He escaped on that boat at night and fell asleep. The average speed of that boat was 30 miles per hour. He was adrift for a total of 8 hours. What is the maximum distance away from that boat? What is the maximum distance our protagonist is from the ship that he escaped? Also, what could have happened is that they could be drifting in the same direction. In that case, what is the minimum? Work on this. I'll have homework for you shortly. You're still here. Well, let me give you homework then. I'm going to tell you some facts about this right here. This has a range of 20 feet and has an airtime of 2 seconds. I want to know the muzzle speed for this. This over here. This has a range of 50 feet. It's got an airtime of 3 seconds. Figure out the muzzle speed. This over here. This over here. It has a range of 100 feet in 4 seconds. Tell me the muzzle speed. That's your homework. Put it on a separate sheet of paper, hand it in to me tomorrow. If you're listening to this, you probably already know I'm not here. But I have a mission for you. But before we start, I'm going to let Mr. Kolb refresh our memories. Mr. Kolb. Thank you, Mr. Kolb. If you look behind me, you should see what is behind you. You see what I did with that? Behind me, behind you. Ah, get it? Forget it. The first formula we covered, speed and velocity. We'll go over this very, very quickly. Get it? Speed, quickly, get it? Get on with it! Fine, fine. So when you change your position, you have a velocity. Oh, Mr. Kolb, nice of you to join us. Whatever. Hey, Mr. Kolb, I have a question. Yes, Mr. Kolb? That's not how we learned it. Speed is distance over time, not position. What is this position thing? I can field this one. Thanks, Mr. Kolb. You see, distance is not a position. A position is where you are. That's where you are. That's where you are. A distance is what lies between. So you can cover this distance no problem. But these two are positions. You can start at position 0 and then go to position 40. Your distance would be 40. If you start at position 10 and you go the same distance, 40, you will end at position 50. That's what we like to call your final position minus your initial position. Now this little 0 stands for initial. Final position, initial position. And that's going to be your distance. This is also known as delta x. The delta, all it means is the difference between these two. Which brings us to our next concept. Whoa! 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 We didn't go over the objective yet. Fine. Take it away, Mr. Kolb. Thanks, Mr. Kolb. Today's objective is to understand the concept of acceleration. Yes, Mr. Kolb. Isn't acceleration the same thing as velocity? No, it isn't. Acceleration is the difference between and that's why you should never tango with a baboon. I am so lost. I never knew you could ride an elephant like that. And your unintentional involvement in the Cold War? You should write a memoir. Still lost. What's a memoir? Look, you explained acceleration horribly. Why don't you let them take a crack at it? Them? Yeah, them. The kids watching this. It's an idea. Fine, that's settled. Here's your mission, to figure out for yourselves what acceleration is. Here are your parameters. Work within your table to come up with a definition for acceleration. You have 2 minutes. Good luck, and Godspeed. I still don't get it. What is acceleration? For those of you who haven't figured this out yet, your notebooks should be out. It's the change in velocity over time. Acceleration is the change in velocity over time. The change in velocity over time. The change in velocity over time. So what you're trying to tell me is that acceleration is the change in velocity over time. Yes, over time. So that's great and all, but how do I use it? What can acceleration do for me? When we have all the equation of kinematics down, kinematics is what we're doing now. We can determine the muzzle velocity of the gun. Big deal. You can use a radar gun for that. Do you have a radar gun? No. You can do it without a radar gun. You can use a timer. No problem. I got this. Are your reflexes fast enough? Well, no, but you can do it without a timer. Fine, whatever. I think we need an example problem to elucidate this elusive. Example. I was on the Garden State Parkway. Not another Garden State Parkway problem. Fine, fine. New Jersey Turnpike. Mr. Kolb, I think you're missing the point. Why don't you tell them about that roller coaster you went on over the summer? Over the summer, I went to Pennsylvania. And that's how I met Michael Vick and received the key to the city. Mr. Kolb, you didn't even mention the coaster. Right. The roller coaster's name is Fahrenheit. For simplicity, we will do this in metric. So, we're converting Fahrenheit to Celsius? No, no, no. We're converting Fahrenheit to metric. That's what I said. Fahrenheit is a name of the roller coaster. It does a hairpin up top and it goes straight down. It shoots you up and then shoots you down. So my question is, what is the acceleration experienced at the very beginning of the coaster? Work in partners to figure this out, and work it out on the board. This should take you between 2 and 5 minutes. Now, there is homework, but you'll get to that soon. Yeah. Welcome back, if you're watching this. You did that already. Right. While I find my place, Mr. Kolb will demonstrate the problem on the board. Now, it says that it goes from 0 to 60 in 2 seconds. 0 to 60 in 2 seconds. Here it's going 0 miles per hour. Here it's going 60 miles per hour. And it says it can do it in 2 seconds. So let's use the formula. Acceleration equals change in velocity over time. What's our change in velocity? Well, what's our final velocity? 60 miles an hour. What's our starting velocity? That's right, boys and girls, it's 0. And finally, what is our time? 2 seconds. Now, the units will get tricky for this, but it'll be a very, very simple answer. Over here, it's going to be 60 over 2. And what's 60 divided by 2? Yep, it's 30. 30. So here's our answer. But what's our units? Well, it's miles per hour per second. Miles per hour per second. Some unit, right? You said per a lot. Can you explain that? So what per means, if you remember, per is that line that goes between the numerator and the denominator. Remember, the numerator is how much you actually have. The denominator denotes the numerator's value. If that's confusing, ignore it. So the numerator and the denominator. So per is this line over here. So you have x over y, and this line is per. X per y. So say you're speeding up. Say you're on the ramp, and it takes you 2 seconds to speed up from 45 to 65, like on the Garden State Parkway. So it's a difference of 20 miles per hour. They've increased your speed by 20 miles per hour over the course of 2 seconds. So you did 20 miles per hour per 2 seconds, or 10 miles per hour per second. Now, there is homework. The homework will be collected and checked for completeness. You may work on it until the end of the period. Goodbye, and I will see all of you tomorrow.